so we're on day 3, chapter 6. So the first day, mainly what we did is multiply. So when we multiplied, what did we do to the powers in the problem? We added them together. Yesterday we did the opposite, we divided, so that made us subtract. What we're going to do today is have some powers there and then go to more powers. So there's going to be a new rule for that. But let me do this one a long way, and then it'll kind of illustrate the point. X cubed means what in factored form? What's x cubed about?
X 2 times?
X.
Or X 3 times?
It would be x times x times x. So this x cubed means x times x times x. If I square that, what does that mean happen?
Times it by itself.
By itself, which means there'd be another
3x's.
3x's. So long way out, grand total that up, we'd get x to the 6th. So I don't think you want to do this like every time, especially on, we have some over there, here's one, x to the 5th to the 6th. I don't think you want to write out that many x's. I think you want to look for a way to do this. What are we looking to do today to the powers? Multiply. 3 times 2, that's how we got the 6. So what we're going to do today is, if there are problems with coefficients, and if you look to the right or down in these corners, there are some problems with coefficients. What you're going to want to do is have the coefficient go to the powers that they're listed there. And then, again, for the 3rd day in a row, copy any bases. You never change any of these bases. So when I get around to this problem, don't change the, which is which number? This 2. This 2 will not change. And what we're going to look to do is multiply powers. So this is a smaller problem. There is no coefficient, so who cared? We copied the base, the x, and then multiplied the powers up to 6. So I'm going to go out of order. I'm going to do this one next. So I'm going to copy the x. New power is 30. I had no coefficient, so don't worry about it. But I take the powers, multiply them, I get 30. That's like the main name of the game today. Something about that. So this x is going to end up to the 12th, but here's an extra step. That isn't going to stay at 3. That 3 is a coefficient. The coefficient, we just have to take it to the power. What does this mean to do if we have 3 and a power of 4? We're doing
4 something. 3.
Yeah, so 3 times 3, which is 9 times 3 again.
27.
27 times 3 again.
Is it 81?
It is 81. And now I might suggest a different path, because 27 times 3 gave us some pause there, because that got kind of big kind of fast. Go 3 times 3.
9.
The other 3 times 3.
9.
9 times 9.
81.
Okay, it's just a different way to group the 3's. If you're doing powers and you're finding the numbers are getting kind of big for you to handle, just give up, write it down, or memorize it or something, and do the rest of the group, and then put the pieces together. This x, what do you think?
2. Oh. 8.
Go up to 8, because we're going to take 2 times 4. This y?
5.
No.
4.
4. This is invisibly a 1, and what are we doing to powers today? Multiplying, so we're up to a 4. How about this x?
6.
Up to 6. How about the 2?
Just stays 2.
6.
No. What did you say?
12.
No.
8.
8, yes. How 8?
It's 2 times 2.
Correct. When you do the coefficients, you may be using your fingers to just count 2's as you do this in your mind. 2 times 2 is 4. Times 2 is 8. 3rd power, 3 fingers, 3 2's, did it out. There's an 8 sitting there. Question about the ones I did so far. If I gave you this, what do you think about this one? It's an A to the M and then that's an N.
MN.
MN for the power.
AN.
The base would be
A.
just an A, never change the base. So this had an A, keep it. Just multiply the powers. If you can't multiply them, just put like a multiplication problem. This, how about this A?
M.
M, because invisibly this had a 1, and the B
M.
to the M. Question about this area before I take a little walk. I think the camera will still do that next call. We're still good on these, I believe. Yeah, so we won't have to move it yet. How about this one?
2 times 10 to the 12th.
It is a 10 to the 12th. I'll agree with that. You want your tests or something?
No, there's a situation.
Okay. Why don't we stop this and we'll see what the situation is. Alright. So this is definitely 10 to the 12th. So we never change the bases, so there's no reason to change the 10. We definitely multiply the powers, so that's definitely a 12. Where we're getting hung up all the time is what to do with these coefficients. A thought on this?
Do we multiply
Would
that
it
by
be
the
20?
4?
Not 20, not multiplied by 4.
Okay.
Would it be 2 times itself 10
16?
times?
2 times
2 times 2 times
Times
2.
2?
Times 2. It's 10 times?
why did I put the brakes on?
2 times 4.
2 to a power of 4.
Oh.
The coefficient is just going to go to the power. We'll check the note over here. The coefficient is going to go to the power we see. So 2 to the 4, like, ignore all that. We got it 2 to the 4th. We've got to do it sooner or later. So 2 times 2, times 2, times 2. There's the 16, and now that's a win. Let me cut down to here. What do you think about this one? That's a scribbly 2.
6 for the power,
6 is the power, agreed.
and then 4 for the... Oh, 8? Confused now.
I don't know what to do.
What's this called?
The base?
What do we do to the base every day this
Copy
week?
it down.
Copy it down. Nothing. 2. Just don't mess with success. The bases are good. So on this problem, who's good? We're not touching them.
2.
The 2.
No.
Oh.
The X.
The X. Why is the X a base?
Because it has a
Because it has a
thing
power.
touching it.
Who else is a base?
The Y.
So don't mess with Y. Y is a base. It has a power. 2 is not a base because it
It doesn't have a power.
doesn't have a power. So the thing we're better at so far is doing what to the power partners?
Multiply.
Multiply. We've been pretty solid at that. That's 20. The X would have a
15.
15. And then the numbers where we fall apart. What you have to do with the numbers is ignore all the powers, the other basey stuff, and just do 2 to the 5th. 2 times 2 times 2 times 2 times
32.
2. Agreed. Question about that, like first idea. This one has a double idea. Because what are these doing?
Multiply.
Multiplying. But there's also an exponent. So how do you know who to do first?
The parentheses. The exponent.
Order of operations.
Order of operations. Parentheses are the win, but there's a couple sets of parentheses. Exponents are next in line before multiply. So we have to do this first. So 2x squared is going to wait its turn. 3x cubed, we're going to do what we've been doing this period.
27.
27 is there. 3 to the 3rd, 3 times 3 times 3, that is a 27 coefficient.
And X to the 9.
X to the 9 is correct. That's a good move. Now we understand today. If we understand today, we get that going first. Question about that. Then flush today. Go back 2 days in history. On the day that we multiplied, what were we multiplying 2 days ago in that homework? What was the rules?
We multiply the bases.
We multiply the bases. 2 times 27, anybody?
52.
Warm, it's in the 50s.
54.
54 is correct. And what were we doing with powers on day 1?
Adding.
Adding. So x
11.
and that's our grand total on that. When you get toward the end of the homework, there's going to be some like combo problems. You're going to have to use today's idea and the old one. Something about that. And then let me slide to the right. Do we need to turn yet, maybe?
A little bit.
A little bit.
That looks
Okay.
good.
This one isn't bad, other than it's in fraction form, and sometimes people see fractions and get a little bit like wigged out about that. But you just do the top as its own problem. You do the bottom as its own problem, and you just let it stay a fraction, and it doesn't have to do anything serious to you. So this A
M.
is an M, because this invisibly had a
One.
1, and we're just multiplying. V,
M.
M, call it a day. And that one. Something there. Fraction the answer this time?
X.
X,
10.
10,
Y.
15.
Y 15. Something about that. Uh-oh, coefficient. We'll see if we're smarter than we were 5 minutes ago. Could save the coefficient for last. if
X
you-
to the 10.
X, that's a, maybe too far away. At 3.
6.
It is a 6.
12.
12 is good. What to do about that? That was stumping us a few minutes ago.
It's
27.
It is 27. If people don't get it, how did you get it? 27 people voices.
I did
Multiply 3.
times 3 times 3.
Correct. And I think we're getting there. Something about that one. And there's 2 coefficients.
Would the power be 12?
On who?
On X.
X does get a 12. Truth.
Y is 8.
Y is 8.
Would 16 be the X's?
The X's coefficient is a 16 from 2 times 2 times 2 times 2. I think we've hit that. We hit that here. We've hit that a few times already today. 3 to the 4th we've hit a few times today too.
80.
And that's in that back to the 81 we had earlier a few minutes ago. Question about those. Take another small turn. This one, we can do one of 2 ways. There's something you can do on these fractions that we couldn't do on the previous column. Does anybody see something that can be done here that couldn't be done a minute ago?
Dividing it.
We can do the division. Okay, over here, we couldn't do 2 dividing 3. Like, that couldn't happen. But you can do 10 dividing 2.
5.
It is. I would suggest, it doesn't matter in terms of being right or wrong if you do the powers first or if you do the divide first. But at some point in this, since 10 can divide by 2, you're going to have to divide those either now or later. If you divide them now, I think it's easier, because if you do the power first, those numbers are only going to get bigger. So I would suggest if you see numbers that can divide, 10 can divide 2, and instead of 2 numbers, you have 1, you just have a 5. I would do parentheses division inside there first if I can, and then do the power. So let's look at this one. Is there anything here that we can make better with like yesterday's dividing kind of lesson?
The 6 can become a 3.
6 can divide by 2, and the 6 could become a 3. And instead of 2 numbers, have 1 number. Can you do anything else?
Could the X's subtract?
The x's we can subtract the powers. So instead of a 5 and a 3,
We could have a 2.
we could just have a 2. And for the y's, instead of a 4 and a 7,
-3.
you could have a -3. Or you could have a regular 3, but leave it on the bottom. That was a discussion that we had yesterday. And then there's not even a fraction left at that point. But if you can divide, I think it's easier. Because if we did the powers, that was going to get kind of big. What was this? Was this a 6?
Yeah.
Okay, so 6 times 6 times 6 times 6? I don't think you're real excited about that. I think you'd rather get the 3 times 3 times 3 times 3 going, because we already know that's going to be 81. We've seen that now like 3 times in this period. X gets
2.
up to 8, so we're multiplying y to
Negative.
negative 12. Let's go back up here. 5 and
8.
5's going to become
25.
25. X,
8.
8, y,
6.
6. Did we lose anybody on that pair? This is like one I did in the second column. This has 2 things going on. What are the 2 things going on this one? That's correct. Multiply, divide. What's up? It's a thing we're going to have to do sooner or later.
Divide.
Multiply. We're going to have to multiply these for sure. What's the other thing that's hiding? Not really hiding. It's there. Other than a multiplication problem, there's also...
Division.
No, I don't, there's no division. You see, I see a multiplication. What else do you see?
Subtraction.
No, I see no subtraction.
Addition.
There's no addition.
2.
There's a 2. There's a power there. So there's a multiplication here. There's a power there. Does it matter what order you do math in?
Yeah.
Yeah, you have to do first out of those 2 the
Exponent.
exponent. So this is going to change. The 3 coefficient upgrades to
9.
9. The x's power
2.
8.
is 8. 4 times 2. Y's power
10.
10 from 5 times 2. So the exponent does this. That's like based on today's lesson, today's new knowledge. Question about the today change. Then forget today. We multiplied 2 days ago. So now think in 2 days ago's rules. 2 and 9 makes 18. We multiplied them. X, new X count, 10, because we added 2 days ago. Y count,
13.
13. Something there. I see a lot of stuff on this monster, and then we'll close out with a simpler thing. What do you see on this one?
Kind of everything.
Yeah, like spot me something we're going to have to do.
Multiplication.
We're going to have to do a multiplication because on the top I see that.
Like the power.
We're going to have to do power where?
The 2 outside the parentheses. Here's
Which parentheses?
the right side.
Yeah, so there's a power on the top to do. There's a power on the bottom to do. And because of this, sooner or later, we're going to have to
Divide.
divide. So out of multiply, divide, and powers, who's the more important stuff to do first? Powers. So start with doing one of those powers, and then the other power. In the old days, we used to have the tiebreaker to work from
Left to right.
left to right. This isn't really a left to right situation. This is a different kind of problem. So just do the powers, do them whenever you do them. There's no left to right. Just like pick a power, then pick the other power. But 2 exponent of 2 upgrades to 4. X new power 6. Y's new power 4. That's like today's lesson. This is out. That stuff's in. But 4 is out.
8. Oh, 16.
16 is in. X
8.
8. Y
10.
10. So that's out. This is in. That's also today's lesson. Question about the today lesson part of that. Multiply and divide, where do they rank?
Same.
They're the same. So I would personally rather probably do the divides. Maybe? I don't know. It's a toss-up. The nice thing about dividing is dividing makes things
Small.
smaller. Let me do the multiply way first, and then we'll divide second, and then I'll do it the way that the other way, and see if you have a preference. But on top, if we multiply, like 2 days ago, 8 and 4,
32.
32, x's
8,
up to 8, y's
7.
up to 7, while this was waiting. And now have a yesterday flashback. What do we want to do with these?
Divide.
Divide. It goes twice. X's?
Or no X.
There's no X's. They like wipe out. Y's?
-3.
And that's perfectly a great answer. Something about that. Alternate plan, if you wanted to divide first, 8 goes into 16
Twice.
twice, and 2 goes into 4
Twice.
twice, and that 2 was on the top, so we got a 2, not a half. For the x's, 8 of them would bump off 6 of them and leave you
2.
2 of them. But 2 of them bump off 2 of them, they're gone. 10 y's versus 4 y's leave you
Negative 6.
6 of them. But when 6 of them bump off 3 of them, that leaves you
Negative 3.
either -3 of them or 3 of them on the bottom if you left it looking like a fraction. If you manage that, I think you thoroughly understand what's going on today. Question up through there. Last tidbit. If I do this versus this, are those the same thing or different things?
Different.
Those are different things. This negative is getting counted
With
how many times?
Twice.
Twice. So this answer would be
25.
25, negative or positive.
positive.
Positive. This negative gets counted
Twice.
once. So this would still be 25, but
Negative.
negative. So if I stroll back over to these problems, let me do one more tidbit of fact and then I'll do a quick scroll. Sorry, false alarm. We had rules the first day when we had a couple absent people. Rules about negatives in parentheses, the powers. Anybody remember either of those rules?
This is even though
Negative go to an even.
it's gonna be positive.
It's going to be positive. And if a negative goes to an odd,
It's gonna be negative.
it's going to come back negative. There are going to be a sprinkling of negatives in your problems today, I do believe. What I would do is do what we did first. Don't even think about the negatives till you're like all done. And then decide, does this negative even matter? And it's like 50-50. So if I put a negative here, it's a negative inside, it's going to an even power. That would make a
Even? Or positive?
positive. So if I put a negative in there, does that even matter?
No.
No. If there's a negative inside and the power is even, it's like it never even existed. So if I do this, does that matter or not?
Doesn't.
Doesn't matter because the power
It's even.
was even. Might have to turn me back, sorry, thank you. This negative, does it matter? Does that matter?
No.
No, because for the third time in a row,
It's
even.
it's an even power, so who cares? If I do this, is it 4 in a row? No, it finally matters. It's a negative going to an odd. Your only adjustment you have to make it negative. So if I do this, adjust or no? Adjust. It's an odd, so adjust. I can't even really talk about this one because we don't even know what the power is, so we just hope they don't do that to you because I don't know what you're even supposed to do with that. If I go like this, is that following that same concept we just did 5 times in a row, or is that a whole new game?
It's new.
Easy or hard?
Easy.
Easy. What do I do?
Throw a negative.
Just throw a negative on it. So if I throw a negative there,
Just throw a negative.
just throw a negative there. What if I throw a negative there?
Then we have to like.
Then we'd have to think through the negative we already thought through, but then this additional negative,
Make it positive.
make it positive. Or another way you could do this is think, this negative, there's 3 of them. This negative, there's 1 of them to total up to 4. And an even amount of negatives makes that back to positive. No matter what you do though, you're gonna land on positive. So if I do this, you could either think negative to an odd is negative, but switch it back. Or you could go, this one counts 5 times, this counts once, makes 6, even amount, positive. You're still gonna get a positive no matter what logic chain you use. Question about what's up with any of this stuff? Alright, let's take a look at the page. And the students are all thinking, please say the word skip. No, it doesn't say skip. And the students are thinking, please don't say a high number. It's not bad. 1 to 22, that's not a high number by our standards. And then try 24, try 26. Working from page 236. So 236, let's see what that is. 1 to 22 are all 22 of those just are single step problems. So from 1 to 22, it's just going to be one grouping going to a power like most of what we did over there. Then we were trying 24 is like a 2-step problem. It's like this one. It has a multiplication, but first a power. 26 is more like the one we finished with, where there was some like divisions and powers and mixed up stuff. But the only ones that are going to take you like a two-step, 3-step plan is 24, 26. Straight up to 22, you're just kind of rolling it, I think. Question, anybody? Shut it down.